So the 11.3 lecture kind of takes us all the way back to chapter 1 when we did what is called the difference quotient. And this thing right here is called the difference quotient. So we've done this before where we put an x plus h wherever we see an x, and then we subtract the function, and then we divide by h. But now what they're doing is they're adding this limit as h goes to 0. So let's take a look at how this would be written. First of all, you should always write the limit as h goes to 0. Now the very first thing I'm going to do is take this x plus h and put it in for x. So it looks like this. So I have some space to put an input, and that's where I'm going to put my x plus h. Now the second time, this part right here, it's just telling us subtract your function. So back in chapter 1, I said put a big set of parentheses down, and now just write your function in that parentheses. And then this is all over h. So this is the limit as h goes to 0. Distribute, we're going to have 3x plus 3h. Don't forget about that 4. And then distribute the negative sign, negative 3x plus 4, right? Double negative there, all over h. Now, some of this stuff should cross off, and typically when you're doing the difference quotient, all the stuff that I wrote in green, the subtracting the function part, that will all subtract off or add up to 0. So there's a negative 3x and a positive 3x. There's a positive 4 and a negative 4. And so the only thing I'm left with is what is the limit as h goes to 0 of 3h over h. So you can divide by the h, and now you're just left with 3. So as far as looking at h going to 0, there's nothing else. So this is basically what is called a derivative or a tangent line. Now, a tangent line, if you remember, is when a line hits a circle exactly in one spot. So if we go back and look at this graph, 3x minus 4 would look something like this, let's just say. Well, it would make sense then that the slope, any point I pick, the slope is always the same. So this will make more sense later in the lesson, but anyway, that's finding the difference quotient. The answer is 3. So now we do the same thing. We're going to do the limit as h goes to 0 of something squared minus 2. So again, I'm putting that x plus h in there wherever I see an x, and then I'm doing that spot. That's subtracting, and I just put my function in there, and it's all over h. All right, so we're at the end of pre-calc here, and so x plus h squared, you should know how to FOIL or box method that. So you're going to have the limit as h goes to 0, x squared plus 2xh. Make sure you get that middle term, and then the h squared. Then there's a minus 2. Then there's a minus x squared and a plus 2 all over h. So again, that's gone, that's gone, that's gone, that's gone. Now these are the only two things that are left. Now notice they have an h in both of them. So I'm going to factor an h out. That leaves behind a 2x and an h all over h. Now I can cross those off, and now we can answer the question. When the limit, what's the limit as h approaches 0 of 2x plus h? So I can take that 0 now and plug it in. if I put the 0 in here, I would have the undefined term. So right after you cross that one off, that's when you put the 0 in. And so that's 2x plus 0, or just 2x. So the idea is, remember this original graph right there kind of looks like this. And if I do a dot here for the tangent line, you might say its slope is -4. Here, the slope would be 0. Over here, the slope might be +4. So that's how you do that. So that's what this one is telling you, is that when you do tangent lines, so they picked a dot, and then they put this line on there. You can see that line. And they just picked a line. So since that line's doing that, they went one to the right and up to match it. So the slope of this one is rise over run, or 2. So at that dot, at 1, 1, the slope is 2, which is like the average rate of change. If I did this dot, the tangent line is here, and the slope is 0. So we've never done slopes of curves, but all of a sudden we're doing that now, and that's what the difference quotient is going to help us do. All right, example 2 is talking about monthly temperatures in Dallas, Texas. So you can see that they picked a dot, 1067, so that's in October, the average temperature is 67 degrees. Now, if I match it, so you can see there's a line there that kind of goes, there's a line there that kind of, you can see it right there, that's hitting right there. And they said the slope is rise, so there's a change, a vertical change of 10, and a horizontal change of 1. Now, you either, in this case, they went up 10 and left 1, so they're getting a -10. And what does this tell us about the slope? According to this graph, in October, there's about a 10-degree loss per month, or the temperatures are decreasing 10 degrees per month is how you would say that. Because degrees is on top, the X or the months are on the bottom. Well, this is the same thing here. So slopes and limits. So what we're going to do is find a tangent line or derivative, same x plus h rule, and then we're just going to plug the numbers in. So what I would say right now is pause the video, see if you can set up the difference quotient. All right, so if you're calculating a slope, you're going to do the limit of the difference quotient. And I would still write limit every time right here, so limit as h goes to 0. But you put x plus h in the first time. Now you're subtracting your x squared. So again, this is setting up FOILing or box method, whatever you want to do. X squared, 2xh plus h squared, just minus the x squared. So the x squareds go away, and you're left with 2xh plus h squared over h. Now if I factor an h out, that means the h comes out of here, so I'm left with 2x. And h comes from here, I'm left with h, and now I can cross it off. And I bring back this limit as h goes to 0. So now that 0 can go into that h, and it's 2x plus 0. So this is my kind of what we'd call our tangent line or derivative. Well, they want us to look at -2, 4. So all I have to do is put the x, the -2, in for x. And now I know that my slope is this -4. So you'll hear me refer to that as the x plus h rule. Okay, so we're going to just do the x plus h rule, and I will help with this one again. So we'll do the limit as h goes to 0. We set it up as there's a 4 and something's going to go in there minus something there, and that's where my x plus h goes. And then we're going to subtract our whole function, so that's where 4x minus x squared goes, and it's all over h. So that's just the basic setup. You always put x plus h in wherever you see an x, subtract your function, divide by h. So now I have the limit as h goes to 0 of 4x plus 4h. Now remember, this is x squared plus 2xh plus h squared. But there's this negative, so I get negative x squared, negative 2xh, minus h squared. Then in green, I have minus 4x plus x squared. So there's a negative 4x and a positive 4x and x squared and a negative x squared. So those are my terms that are left. So it's going to be the limit as h goes to 0. I'm going to factor out the h away from the 4. I'm going to factor in h away from the 2xh, so just the 2x. And when I do this term, it's just a negative h. So those go away. And now we're left with the limit as h goes to 0 of 4 minus 2x minus h. So I can go ahead and take that 0 and plug it in, and I'm left with just 4 minus 2x. Now they want me to calculate the slope. So what I do is I say the slope, so maybe at x equals 3, all I'm going to do is put a 3 in for the x. And the slope is 4 minus 6 or negative 2. All right, so example number 3, go ahead and do your x plus h rule, and let's see what you come up with. All right, so let's go over and look at example 3. All you're going to do is put x plus h in there. And so I put x plus h into the x squared. Don't forget about this plus 1. I really don't need these brackets. Then you say minus all of the function. So it's x squared plus 2xh plus h squared. Don't forget about the plus 1. And then you distribute negative x squared and negative 1. Cross everything off. But you should end up with a 2x. Because once you cross off the h's, I'm left with 2x plus h. And now I put the 0 in. And so it's 2x plus 0 or just 2x. Now put negative 1 in and put 2 in for those slopes. So when you put negative 1 in, 2 times negative 1 is negative 2 for a slope. And I would write this as m equals negative 2. And do the same for the 4. All right, so number 5 is a true DIY. Find the x plus h rule. And then when you get that done, put negative 3 in for the x and put the 2 in for the x. Now, when you do this one, watch order of operations. Do x plus h squared, then distribute the 2 through there. So let's see what you come up with. All right, so if I go over and we look at the answer, 2 times x plus h, that's the first part. Then you're subtracting your function. FOIL or box method to get this. Then take the 2 to every one of these terms. And then you should have, all the way through, got 4x for your final answer. So then you put negative 3 in for the x, and you put 2 in for your x. And again, I would say my slope is, so people know you're talking about slope, the slope is negative 12. When you go into, those of you that go on to calculus, many of our pre-calc students do go to calculus next, you will start to do derivatives. And if you notice, f prime is what they call it. the limit as h goes to 0, there's our x plus h rule. So you're doing the limit as h goes to 0 of the difference quotient. Same thing we've been working on. Call it a tangent line, whatever. Go ahead and do it. So I'll do this one with you. So I'm going to do it a little bit faster now. So we have 4, and I can do x plus h there, minus 5, x plus h. I will be subtracting my function, and this is all over h. Now I know that x plus h squared is that x squared plus 2xh plus h squared. So if I multiply all those by 4, I get 4x squared plus 8xh plus 4h squared minus 5x minus 5h plus 4x plus 5x, 4x squared plus 5x all over h. So my 5x goes away because this one is negative. 4x squared, when I distributed this, it's showing up. I accidentally wrote positive. It's supposed to be negative. So that'll get rid of the positive 4x squared. So these are the 3 terms that I have left. And I do the limit as h goes to 0. I factor out an h. That leaves 8x plus 4h minus 5. Now if you cross those off and then put the 0 in there finally, I'm left with 8x minus 5 for my derivative. Now I can find the slope of that, or the instantaneous rate of change, the slope at a particular point. So, all right, do number 2 as a DIY and see what you get. All right, so hopefully you had time to do number 2 as a DIY. So let's go over and look at the answer. I put an x plus h, it gets squared. Put another x plus h. Don't forget about the minus 2. Then I subtract all of my function. So you've done this a few times now, so that's x squared, 2xh plus h squared, and do all the work, and you should end up getting this 2x plus 1 for your derivative. All right, so now if I'm going to do a derivative of this rational expression, when you get to calculus, you learn other tricks, but for now, we're just going to do it with the x plus h rule. So, limit as h goes to 0. The first time I put x plus h in the function minus my function, and this is all over h. So what I would like to do is up top here, get a common denominator. So I'm going to take the x, this x right there, and put it on the top and the bottom over here. And I'm going to take this denominator and go x plus h over x plus h. So what you'll see is right here and here, I have a common denominator, and I'm just going to go like this. And I get x times 1. Now be careful here. I'm going to take this negative 1 and distribute. So I get negative x minus h. Now, this thing right here is dividing by h. Mathematically, another way to say divide by h is to multiply by 1 over h. So if I start to clean things up, x minus x would go away, and negative h divided by h, I can go like that, and now I'm left with the limit as h goes to 0 of negative 1 over x x plus h. Put the 0 in there, and I have negative 1 over x squared. So rational expression, a little more difficult, but still within our capabilities. And that's 11.3.